Our group is representing the topic of chemical bond. Next, I will present the subtopic 1, which is basic of compound formation. The introduction. Sodium Na is reactive toward chlorine gas Cl2 when heat and form a white solid. Did you know that this white solid is the table salt that you use in your daily life, like in this picture? However, no compound is formed when sodium Na is heated with neon gas Ne. Do you know the reason why? So, the next slide, I will explain to you the real reason of this reaction. Compounds are formed when two or more elements are combined. Do you know on how the elements are combined to produce the compound? Next, normal gases exist as a monoatomic gases and are not reactive chemically because they are achieve a stable duplet or octet electron arrangement. However, for atoms of other elements beside noble gases, the stabilities of arrangement can be achieved by transferring or sharing of electrons. So, what is the compound that I explained it before? The compound is, we call it as chemical bonds. Chemical bonds are formed when electron transfer or electron sharing take place. These chemical bonds have two types, which is ionic bonds and covalent bonds. Chemical bonds is only involve the valence electron. As you can see in this slide, we have two pictures. For the picture 1, you can see that electron is transferred to another electron. This formation, we call it as ionic bond. For the second picture, you can see that atom hydrogen is sharing with another atom hydrogen, and we call it this as formation of covalent bond. So I will just make it simple. For ionic bond, is involved with transfer electron. Meanwhile, for covalent bonds is involved with sharing electron with the same elements.
An ionic bond is the force of attraction between two oppositely charged ions. This happens when one atom gives up electrons and another atom takes them. In this example, sodium loses one electron and became a positively charged ion called a cation. Fluorine gains that electron and becomes a negatively charged ion called an anion. This transfer of electrons makes both atoms more stable and creates a strong bond between them. Metals like sodium form positive ions, while non-metals like fluorine form negative ions. Some of the ionic bonds properties. The first one is ionic compounds are solid at room temperature because of the strong bonds between ions. The second one is they have a very high melting and boiling points due to the strong ionic bonds. The third one is they dissolve easily on water but insoluble in organic solvent. The last one is ionic compounds conduct electricity only when dissolved in water or in a molten state, as the ions are free to move. This is the example of formation of ionic bonds. Sodium will donate one electron to achieve a stable octet electron arrangement, while fluorine will accept one electron from sodium to achieve stable octet electron arrangement. Sodium and fluorine of opposite charges will attract one another by strong electrostatic attraction force that known as ionic bonds. A compound sodium fluoride is formed. Ionic compounds play an important role in our everyday life. Here are a few examples. The first one is sodium chloride, NaCl, commonly known as table salt. It is essential for cooking and preserving food. The second one is sodium bicarbonate, NaHCO3, also called baking soda, is widely used in baking and cleaning. The third one is sodium hydroxide, NaOH, found in drain cleaners, mostly used to unclog pipes. The fourth one is magnesium sulfate, MgSO4, known as Epsom salt. It's used for bath and as a laxative. The last one is sodium hypochlorite, NaOCl. This is bleach, mostly used for cleaning and disinfecting.
Covalent bonds is a type of chemical bonds that holds atoms together in molecules. They are formed by the sharing of electrons between two or more atoms. This allows each atom to achieve a stable electron configuration. So there are 5 common properties of covalent bond. First one is it exists in the shape of solid, liquid or even gases. Second one is it has low melting and boiling point. Third one, it do not conduct electricity. Fourth one, it is insoluble in water but it is soluble in organic solvent. Next, we will talk about characteristics of covalent bond. First one is covalent bond formation through electron sharing. Covalent bonds are formed by the sharing of one or more pairs of valence electrons between atoms. This sharing helps atoms achieve a stable electron configuration, like I said just before, often following the octet rule. The second is bond types. Covalent bond has 3 types of bond that are single bond, double bond, triple bond. Each number indicates how many pairs of electrons it shared. The more electrons it shared, the stronger the bond. The third characteristic is polarity. There's 2 types of polarity. First one is non-polar covalent bonds. Electrons are shared equally between atoms with similar electron negativities. The second one is polar covalent bond. Electrons are shared unequally due to a difference in electron negativities. This creates partial charge, negative and positive. Fourth one, bonding energy and stability. Covalent bonds store chemical energy and contribute to the stability of molecules. Breaking covalent bonds require energy input, while bond formation release energies. Fifth one, reactivity. Covalent bond compounds can participate in various chemical reactions. Reactivity often depends on few factors such as bond polarity, bond strength, and the molar structure. So these are examples of application of covalent bonds in real-life uses, such as formation of organic molecules, pharmaceuticals and medicine, everyday household product, food and beverage, and lastly, electronics and technology. That's it for me.
What is hydrogen bond? Hydrogen bonds are weak attractions between a hydrogen atom bonded to a highly electronegative atom like nitrogen, oxygen, or fluorine, and another nitrogen, oxygen, or fluorine atom in a different molecule. For example, water molecules can form hydrogen bonds with each other. Role of hydrogen bonds in life. Protein molecules form hydrogen bonds among one another in the hair structure. Do you know why hair sticks together when wet? When hair is wet, protein molecules no longer forming hydrogen bonds with each other. Instead, they form hydrogen bonds with water molecules. Water molecules also bond with other protein molecules in the hair, causing the hair to stick together. Effect of hydrogen bonds on the physical properties of substances. Compounds in liquid form reach the boiling point when the attraction forces holding their molecules together are overcome. In ethanol, there are strong hydrogen bonds between molecules along with weaker van der Waals forces. Breaking the weak van der Waals requires more heat energy besides hydrogen bonds, which is why ethanol has a high boiling point. In contrast, molecules like chlorine, which don't form hydrogen bonds, have lower boiling point. Ethanol is also soluble in water because it can form hydrogen bonds with water molecules.
So, what is dative bond? A dative bond, also called a coordinate covalent bond, is a type of covalent bond where both electrons in a shared pair come from the same atom. This occurs when one atom with a lone pair of electrons, the donor, bond to another atom or ion that has an empty orbital that we call the acceptor. Unlike a regular covalent bond where each atom contributes one electron, a dative bond is formed entirely by donor electron. However, once formed, the dative bond behaves the same as a normal covalent bond in terms of strength and properties. Next, characteristic of a dative bond. First one, electron donor and acceptor. For the donor, the atom donating the electron pair is called a donor, usually a species with a lone pair of electrons. Example, nitrogen and oxygen. Next, the atom accepting the electron is the acceptor, often an electron deficient species like a metal ion, a molecule like a boron trifluoride. Second one, notation. A dative bond is often represented with an arrow pointing from the donor to the acceptor. Third one, bond strength. Once formed, a dative bond has the same strength and length as a regular covalent bond. Example for dative bond. The nitrogen atom in ammonia donates one pair of electrons to the vacant orbital of the boron atom in the boron trifluoride. So, the nitrogen atom is the donor and the boron atom is the acceptor. Application of dative bond. First one in biochemistry. Dative bonds are crucial in hemoglobin, where oxygen O2 form a dative bond with the iron in the heme group. Next, metal enzyme use dative bonding to stabilize substrate during catalysis. Second one, catalyst. Transition metal in catalyst often form dative bond with a reactant, facilitating chemical transformation. Last one, acid-base chemistry. Dative bonds are key in Lewis acid-base reaction, where a Lewis base donates a lone pair to a Lewis acid. Like example just now, a boron trifluoride BF3 is electron deficient and accepts a lone pair from ammonia, forming a stable adduct or addition product.
What is metallic bond? A metallic bond is a chemical bond that occurs when metal atoms share their valence electron, forming a cloud of electrons that surround positively charged metal ions. So, here are some examples for metallic bond. So, as you can see on my right side, there is a picture which describes about a metallic bond, which stated that electrostatic attraction between the electrons, which is the small blue ones, and metal ions, which is the A plus circle one. So how does it work? Metal atoms are tightly packed together in a solid. The valence electrons of the metal atoms are not tightly bound to the nucleus. The atom that lose their valence electrons become positively charged ions. The valence electrons are free to move around from one atom to one another, forming a sea of electrons. The attraction between the positive ions and the sea of electrons creates a metallic bond. So, here are the characteristics of metallic bond. First, strength. Strength are a strong attraction between the protons in the nucleus and the electrons in the orbitals make metals very strong. Next is malleability. Metals can be bent and shaped into different forms. Next is ductility. Metals can be stretched into long, thin wires. Then electrical conductivity. Metals are good conductors of electricity because of movement of the electrons. Next is thermal conductivity. Metals can conduct heat, but the amount of heat depends on the type of metals. Next is luster. Metals have a shiny appearance because the electrons on the surface reflect light energy. So here are applications of metallic bonds in our daily life. First are gold coins. Gold coins are lustrous or shiny. Metals are known for their shine, and this is utilized in the materials like jewelry. Next is iron. The localized electrons allows for heat movement through metals. An iron uses a metal base to transfer heat to clothes. Third one is spring. Metals can be stretched into thin wires. This is possible due to metallic bonds and their ability to break and reform. Next is stop signs. Metal can be compressed into very thin sheets. Road signs are created with metal compressed into sheets and coated in paint. Next one is hammer. Metals are very strong, even though metallic bonds can break and reform. This allows for impact on metals to be absorbed without breaking, like with a hammer. Lastly, a light bulbs. Metallic bonds allow for good conductivity of electricity. Light bulbs like these are made with tungsten metal filament to create white lights. So that's all from us. Thank you.